Hi everyone. In lab and in the last few notes you've been looking at matter. Now matter is actually one of two things in the universe. We classify the stuff in the universe into two categories, matter and energy. Energy is things like light, heat. You can't really pick it up and hold it, but it causes things to change. Matter, on the other hand, you can definitely pick up and hold. You can see it, you can feel it, you can interact with it. And we divide matter into two categories. There's pure substances, and there's also mixtures. Now these are exactly what they sound like. If something's pure, that means it's the same throughout. It doesn't have anything else in it. It's one kind of thing. Whereas a mixture is made up of a variety of things, all jumbled together. These are further divided into groups. Pure substances can be elements, or they can be compounds. Mixtures are also divided into groups. There are homogeneous mixtures, and there are heterogeneous mixtures. Now, hopefully you guys are familiar with these terms homo and hetero. You've probably seen them before. Homozygous and heterozygous in biology. Remember, homo just means the same or similar. So in a homogeneous mixture, it all looks the same. So same throughout. That does not mean that it's one kind of matter. It just means that whatever the matter is in there is mixed very, very well. So if you made Kool-Aid, you can't pick out individual grains of sugar and flavor and water. Every one of those particles is in there, and they're all separate particles, but they are mixed together. Heterogeneous mixtures, on the other hand, they are noticeably different. So you can see the little chunks in there. And so if you've ever had Italian dressing or a chocolate chip cookie, you've got different pieces in there that you can definitely notice and see, so that makes them heterogeneous. Now back over here on the pure substances side, compounds, these are two or more different atoms bonded together. So two different types of atoms. And bonded is key to that. Bonded means that they are locked together and cannot be broken apart. So that's what makes it pure. I can't break it apart into smaller pieces, even though it's made up of different kinds of pieces. Over here in mixtures, I can break those pieces apart because they're not really locked together. Elements are only one type of atom. Okay. Now, there's something I want you to know that I did not put in the notes, and that has to do with elements and compounds. Okay. Every single element has a name. There are about 118 or so elements that we're aware of or have made, and every single one of them has a name, and every single one of them also has a symbol. Now the symbol of an element is unique to the element. Okay? So you guys are familiar with oxygen. It has the symbol O. You're probably familiar with lithium because you've heard of lithium batteries. This is Li. Okay? These are elements. You'll notice if there's one letter, it's a capital O. If there's two letters, the first letter is capital, the second letter is lowercase. So hydrogen, capital H. Helium, capital H, lowercase e. This is the element symbol for helium. This is the element symbol for hydrogen. Now, a compound actually will have two or more of these. So water is actually H2O. That H2 means two hydrogen atoms bonded to one oxygen atom. So there's understood to be a 1 there. We just never write it. There are a couple things that tend to be a little bit tricky. One of them is when we have a single element that's written like a compound, like oxygen or nitrogen. Both of these are written N2 or O2. Now this is an element. It's the element nitrogen. The little 2 here just means there's two atoms that like to stick together. Same with the oxygen. So these are both elements even though they have the subscript. In order to be a compound, it needs another kind of atom mixed with it. Now the other thing that gets a little bit confusing sometimes is things like CO versus CO. This is an element, and I can tell it's an element because it's a capital C and a lowercase o. That's an element symbol. It's the symbol for cobalt. This is a compound, and I can tell because it's two capital letters next to each other. That's carbon monoxide. Okay. Cobalt is a metal. They put it in like drill bits or hard steel so that it can hold an edge longer. Carbon monoxide is a toxic gas. So one capital letter makes a big difference. So pay attention to your element symbols. The other thing that sometimes confuses students is when the symbol doesn't seem to line up with our name for something. So gold actually has the element symbol AU. Now gold is an English word, and this is from the Greek, I believe, aurum for gold. So I won't make you memorize the periodic table, but you can use it to find the symbols for all the different elements.